we are going to do a quick review of probability. So probability of an event measures the likelihood that the event will occur. So it's a number from 0 to 1 written as a ratio or a fraction, such as 1/2, 3/5, 9/10, or it can be written from 0% to 100%. So key terms for probability. An experiment is an actively involving chance in which results are observed. Each observation of an experiment is a trial, and each result is an outcome. A set of one or more outcomes is an event, and the sample space is a set of all possible outcomes for an event. So let's look at how probability is written. So probability of an event, oops, I forgot to erase that, sorry. So the probability of an event is the number of times an event occurs over the total number of equally likely possible outcomes. So let's say that you rolled heads, let's see, probability of heads. And let's say you rolled it 8 times out of the total number of equally likely possible outcomes. So you rolled it maybe 15 times and you got heads 8 out of 15 times. This is how you're expected to write probability. So an event and its complement, the sum of the probabilities of an event and its complement equals 1. So let's say we're talking about the probability of rolling a number 5 on a number cube. So there's 1 5 on a number cube out of 6 possible sides. So the probability of a number 5 is 1/6. So the probability and its complement, the complement makes up the rest of the whole. So the probability of the event is 1/6. And the complement, if you add it together, it will equal 1. So it's essentially the probability of it not being the number 5. So it would be the probability of it being 1, 2, 3, 4, or 6. So the remaining options, there's 5 remaining options out of 6. So of course we have our common denominator, so 5 plus 1, it would be the same as 6/6. So the complement is the probability of it not happening. So not whatever it is. Okay. All right, so next part, we're going to take a closer look at experimental probability. So there's experimental and theoretical probability. With experimental probability, it's found by comparing the number of times the event occurs to the total number of trials. So let's say we're talking about the probability of someone getting free throws. So the probability of someone making free throws. So let's say they make 9 out of 12 shots. We would use that probability, or the experimental probability, to make predictions, to see what we would say could happen if they did more trials. So experimental probability is the number of times the event occurs. So like I said in the last situation, they got 9 free throws over the total number of trials, over 12 shots. So theoretical probability. Theoretical probability is the probability that an event occurs when all of the outcomes of an experiment are equally likely. So let's talk about like flipping a coin. So the probability of heads. So how many heads are on a coin? There's 1 head on a fair coin out of 2 possible options. So theoretical probability is essentially what has to happen based on the number of sides. So there's 1 heads on a fair coin. We know that. There's 2 sides. What if we're doing the probability of an even number on a cube? So that would be 2, 4, or 6. So there's 3 even numbers out of a total of 6 sides, and you can reduce it to 1/2. So theoretical probability is written as the number of times the event occurs, or you've heard it as the favorable outcomes, the number of favorable outcomes over the total number of equally likely outcomes. And then application of probability. So a simple event is where there's only one outcome for an event. So a simple event would be flipping a coin, rolling a dice. And then a compound event is an event that includes 2 or more simple events. So say I flip a coin, then roll a dice. So in order to find the probability of the 2 events occurring, we are going to multiply the probability of each event to find the probability of the combined events occurring. So let's say I flip a coin, so the probability of getting heads is 1/2, 1 head over 2 sides. And then let's say the probability of getting a 5 or 6. So 5 or 6, that's 2 options out of 6 sides. Reduce it to 1/3. So now I'm going to multiply my probabilities. So 1/2 times 1/3, multiply across. 1 times 1 is 1, 2 times 3 is 6. So the probability of both events occurring would be 1 out of 6. So there are things such as independent and dependent events. So events are independent. That means they do not rely on each other if the occurrence of one event does not affect the probability of the other. So for example, flipping a coin and then rolling a number cube. So flipping a coin and neither one affects the other. They're completely separate occurrences and one does not cause the other to change. Now a dependent event, the occurrence of one event does affect the probability of the other. So for example, let's say I have a bag of candies and I take out a grape Jolly Rancher and I eat it and I don't put it back, then that affects how many are in there. There's one candy missing and it's a grape flavor. So the number of outcomes changes for the second event. So let's say I have 15 candies and there were 9 grape. And I want the probability of taking a grape out twice. So the first time it's 9 out of 15, but the second time there's only 8 grape because I ate a grape, and there's only 14 total. So the number of outcomes changes for the second event. We went from 15 to 14, and the number of favorable outcomes may change. If I was looking for something other than grape, then that number wouldn't change, but the grape changed because I ate one. Now in the same problem, if I pulled out the grape and I said, hey, I don't like this candy flavor, and I put it back, then it would be independent because it was replaced. So I'm going to add replacement to independent. Okay, and then making predictions with experimental proportions. So we use a proportion. Let's say like our free throw situation. We said they made 9 out of 12. Well, first I'm always going to simplify. So I can divide them both by 3. So 3/4. If that's his track record, or if that's what the experiment was, how many free throws would he make out of 100, let's say? So he made 9 out of 12. How many would he make out of 100? So you do 3/4 equals x over 100. You do your cross product, 4x equals 300, and x would equal 75. So same situation over here. They're saying if something occurs 1 out of 5 times, how many times would it occur out of 275 times? So again, we're using a proportion to help us. All right, that's it, guys. Probability is just more ratios and proportions. Just remember, it's generally what you are looking for over your total.